Welcome to the third part of this lesson about combinations of transformations. We're going to be going through two questions in this video. It reads, find the rule of the image when this is dilated by a factor of 3 from the x-axis and a factor of 2/5 from the y-axis, followed by a reflection in the y-axis, and then a translation 3 units in the positive x direction and 4 units in the negative y direction. So there's a lot going on here. We can do this by inspection, but you have to be really careful, and I don't think I would recommend people do it by inspection. There's just too many places where things could go wrong, but let me show you how you would do it. So if we were to do this by inspection, let's just give ourselves plenty of room here and write out our original. All right, so we're just giving ourselves plenty of room. The first thing we're told, it's dilated by a factor of 3 from the x-axis. Well, that means we're just going to put a 3 out the front. We're also told it's dilated by a factor of 2/5 from the y-axis. So that means we take the reciprocal of this and substitute it into the x spot. So it's going to be 5 on 2x. Then followed by a reflection in the y-axis. So this means it's going to be negative here. So I'm putting a negative here as opposed to outside. And then a translation of 3 units in the positive x direction. So that means I replace my x with x minus 3 because it's in the positive direction, and then 4 units in the negative y direction. So then it's going to be minus 4. If I was just to write this a bit neater, it's minus 5 on 2, x minus 3, x minus 3, close my brackets. So that's what I'm saying the answer is going to be. But I personally think that that might be a little tricky to do that by inspection, and that's why I would recommend people do it by the method. By the method. All right, so let's give this a go. So we know how we start these off. We're going to start off just by kind of giving ourselves some bearings here. So we're going to write that down, then we're going to rewrite it, and we're going to be very careful. X dash is going to be what? Well, I have a dilation of 2/5 from the y-axis, so that means it's going to be 2/5 x, and I also have a translation of 3 units in the positive x direction, so I plus 3 here. I also have a reflection in the y-axis, so actually I jumped the gun here. Make sure you follow the sequence the question gives you. So first the dilation, followed by the reflection in the y-axis, so that means it's going to be minus here, and then a translation of 3 units in the positive x direction, so that means I plus 3, and that's it for x dash. Y dash is going to be 3y because of this dilation of factor of 3 from the x-axis, and then it's going to be 4 units in the negative y direction, so minus 4 here. The next thing that I do, having done that, is I create my equation. It's going to be x, sorry, let me write it out like this, minus 2/5 x plus 3 is equal to x dash, and 3y minus 4 is equal to y dash. Then I'm going to fix this up. I'm going to solve it for x. Minus 2/5 x is equal to x dash minus 3, which means x is going to be equal to negative 5 on 2 x dash minus 3. And then over here, I'm going to get 3y is equal to y dash plus 4. And then y is equal to y dash plus 4 over 3. Now, I'm going to write out what my original was. It was this. And into my y spot, I will be substituting that in there. Plus 4 over 3 equals, then into my x spot, I'll be substituting this, negative 5 on 2, x minus 3, close brackets. Then I'm going to drop the dashes and solve for y. So it's going to be y dash plus, actually let me drop the dashes, y plus 4 equals, I'm going to times both sides by 3, so it's going to be a 4 there, minus 5 on 2, x minus 3. Then I'm going to minus 4 to each side. Y is equal to 3. This, x minus 3 minus 4. So that is going to be my answer right there. And as you can see, that is the same as what we started with, what I did by inspection. Let me now walk you through, help you visualize what's going on here. So let me bring up Desmos, trusty Desmos. Okay, and let me just get the question in front of me so I can read it out as we go. Okay, so here it is. So I've just drawn the original graph here. So I've just drawn it in black and red. Okay, so the first thing we have to do is a dilation by a factor of 3 from the x-axis. So that means I'm just going to put a 3 in front, and as you can see, it moves away from the x-axis. And then we have a dilation by a factor of 2/5 from the y-axis. So that means in my x spot right here, I'm going to replace it with 5 on 2x. And as you can see, hopefully you could see there, if I'll try to make this a bit clearer. If I just get this, Control X, what's going to happen when I put that in there is that I'm going to go closer to my y-axis because it's a dilation of 2/5 from the y-axis. 2/5 is obviously less than 1. So when I apply it, I should get closer to the y-axis. And as you can see, I did. Okay, followed by a reflection in the y-axis. If I'm reflecting in the y-axis, that means my negative is going to be here and ready. Hopefully this works. It does, hooray. Then the next thing that we're going to do is a translation of 3 units in the positive x direction. So that means I'm going to replace this x with x minus 3. Whoa, whoopsie daisy, sorry. Let's try that again. So I'm going to replace this x with x minus 3, and it should move 3 units in the positive x direction. It did. So as you can see there, that is now, whoops, that is now 3. And then lastly, 4 units in the negative y direction. The easiest of them all. Minus 4 goes 4 down. And you can see this is now 3, negative 4. And that's what we're doing. So that was our final answer there. So hopefully all that makes sense and you just kind of have a visual understanding of what's going on here. Okay, let's now go on to this question right here. Okay, so this question is a little different. And while I read it, hopefully you can pick up on how it's different. It says, find the rule of the image when y equals x cubed is translated by 4 units. Translated by 4 units in the positive x direction and 1 unit in the negative y direction, followed by a reflection in the x-axis, and then dilated by a factor of 2 from the y-axis. So as you can see, the first thing I do is translate, then I reflect, and then I dilate. So hopefully you can notice that previously what we have always done is we've always done our dilations first. Then we did our reflections, and then we did our translations. So this one has done the opposite thing, but the most important thing for you to remember is you just need to follow the sequence that the question gives you. So here, notice that it uses the words like followed by and then. Those are such key words because it tells you that there's a sequence by which this is happening. We're going to do this question just by the method, by the method. So we begin by writing out this. Rewriting it. And now it's very important that we follow the sequence that we're given here. So the first thing that happens is 4 units in the positive x direction. So I'm going to get x plus 4. Let me just deal with the x's first. And then it says followed by a reflection in the x-axis, so I don't have to worry about that, dilated by a factor of 2 from the y. So that affects my x value. Now we've already translated it 4 units. So now we're going to actually dilate that whole thing by 2. Because remember, the sequence matters. So we've already translated it 4 units in the positive x direction, and then we're going to dilate it by a factor of 2. Okay, now when we're dealing with our y, it's going to be, the first thing we do is 1 unit in the negative y direction. So that's y minus 1, and followed by a reflection in the x-axis. So that means that this whole thing is reflected. So this whole thing will become negative. So the fact that it's followed by a reflection in the x-axis means I'm going to change my y, but because I have already translated it 1 unit in the negative y direction, the whole thing has a negative at the front there. Okay, let's keep on going. Okay, so I'm going to end up with 2x plus 4, sorry, whoopsie daisy, 2 brackets x plus 4 equals x dash. and then brackets negative y minus 1 equals y dash, like that. Having now done that, the next thing that I'm going to do is I'm going to solve for x. So that means I'm going to end up with x plus 4 is equal to x dash over 2. And then x is equal to x dash over 2 minus 4. So too over here, I'm going to end up with negative y dash. And then finally, y is equal to negative y dash plus 1. I'm just going to highlight these because they are very important, because they are what I'm going to sub into my other one. So again, the key takeaway here is the fact that, you know, we've got brackets and we're dilating the whole thing here, or we've got brackets and we're reflecting the whole thing here. That's how this one is different. And it just goes to show you, just do what the question tells you. Just follow the sequence of the question. Okay, what was the original graph we started with? I forgot. X cubed. Y equals x cubed. Into the y spot, I put this. Negative y dash plus 1 equals. Into the x spot, I put this. X dash over 2 minus 4. Cube that. And then I'm just going to drop the dashes and rearrange. I'm going to end up with, let me just keep that like that for the time being. X over 2 minus 4 cubed minus 1. Y is equal to, now this whole thing is going to become negative. Negative x over 2 minus 4 cubed plus 1. Now be careful here. Be very careful. I'm dividing this whole thing by negative 1, and I'm dividing this whole thing by negative 1. So this becomes negative, this becomes negative, and negative and negative make it positive. That's why that's positive. Then, as we're on here, I might just talk about this. We don't like writing it in this form. Most of the time, we kind of like our x just being by itself. So that means what we could do here is I could take out this factor of a half here, which would leave the x by itself. So I went x, I got rid of that, and now what I'm going to do to get rid of, because I'm taking out a factor of a half, so that means this is going to become 8, because it's 4 divided by a half, which is 8, and then all of that is still being cubed like that. Now, if this whole thing is being cubed like so, what's going to happen here is, now we have to be careful, it's going to end up being this. So this will be cubed and this will be cubed. And I'm going to end up with that, because 1 cubed is 1, 2 cubed is 8, x minus 8 cubed plus 1. Whoa, that's going to be my answer. That was pretty cool. Okay, let's now bring up Desmos and just kind of walk our way through this question and show you what we did. So, I think I'll need to bring up Desmos here. This one. Okay, so let's go through this. So what we did here is, let me get rid of this, So we started with this, and the first thing we do, let me just get up the question, is we translated 4 units in the positive x direction. So I come here. As you can see, that moved 4 in the positive x direction. Then we went 1 unit in the negative y direction, minus 1. Then the next thing we did was followed by a reflection in the x-axis. Now, if I'm reflecting in the x-axis, the entire thing becomes negative. So I'm going to put brackets around the entire thing here and make it negative. And bang, it reflects in the x-axis. And then I'm going to apply a dilation by a factor of 2 from the y-axis. So that means I replace my x with the reciprocal of the factor, which is going to be, well, the reciprocal of 2 is a half, so it's going to be x on 2. And that now is my answer. Now, the answer that we got was, I was just to bring this here. Actually, let me just do this for a second. Sorry, I'm just going to do some rearranging. Let me just bring this down. Like that. Then I'll bring this here. That way I can look at it. Let me just prove to you now that what we have written here is the same as what we find here. So if I was just to rewrite this, it's going to be y is equal to negative 1 on 8. Then it's going to be x minus 8 qubit plus 1. And as you can see, that's directly over the green line. So there's the black line. Oh wait, there's the green line, there's the black line. Green, black, green, black. So it's the same thing. Okay, that's everything. So for the moral of the story of this one is follow the sequence that the question gives you. And the moral of this one is be careful. Okay, so hopefully you found these useful. And this is the end of the lesson. Hopefully you found this manageable. I know this concept is kind of hard. For many students, they find this a very difficult portion of methods, but hopefully you just persevere, keep doing your exercise questions, and you'll be fine. All right, see ya.